Question 12, Part C. The graphs of y equals tan x and y equals cos x meet at the point where x equals alpha as shown. Part 1. Show that the tangents to the curves at x equals alpha are perpendicular. Let f of x equal tan x and g of x equal cos x. Then the gradient functions of their respective tangents are given by f dash of x equals sec squared x and g dash of x equals negative sine x. Now the tangents are perpendicular if the product of the gradient functions f dash of x and g dash of x equals negative 1 for some value x equals alpha. So sec squared alpha times negative sine alpha is equal to 1 over cos squared alpha times negative sine alpha. Now, negative sine alpha over cos alpha is equal to negative tan alpha. And that's how we get negative tan alpha in the numerator here. And that's divided by cos alpha. Or we could express it as a product as negative tan alpha times sec alpha. Now, at x equals alpha, f of x equals g of x. That's the point of intersection of the two curves. In other words, tan alpha equals cos alpha at the intersection point. Hence, negative tan alpha over cos alpha equals negative 1, or we could say negative tan alpha times sec alpha is equal to negative 1. Therefore, the tangents to the curves are perpendicular at x equals alpha. Part 2. Use one application of Newton's method with x1 equals 1 to find an approximate value of alpha. Give your answer correct to 2 decimal places. Let y equal tan x minus cos x. Then the gradient function y dash is equal to sec squared x plus sine x. Don't forget that the gradient function gives us the gradient of the tangent to any point on that curve. Now ultimately we will need to find the equation of the tangent at a specific point, namely at x equals 1. But we need the function value or the y value at x equals 1. So let's work that out first. So at x equals 1, y is equal to tan 1 minus cos 1, and the value of the gradient function, or the gradient of the tangent at the point where x equals 1, is sec squared 1 plus sine 1. Now the equation of the tangent to the curve where x equals 1 is given by the point gradient formula y minus y1 is equal to m outside of x minus x1. Now our y1 in this case is tan 1 minus cos 1. Our m, or the gradient, is sec squared 1 plus sine 1 in brackets, and our x1 is 1. Now we're interested in the point where the tangent crosses the x-axis. In other words, the x-intercept of the tangent, because that's our approximation to alpha. Now at the x-intercept, y is equal to 0. So what we're going to do is let y equal 0 and then solve this entire equation for x, where x becomes our approximation using Newton's method. So let y equal 0 and solve for x. So rearranging the equation to make x the subject, so if we let this equal 0 here, we've got negative tan 1 minus cos 1 in brackets. We're going to divide that by our m. So we're going to divide that by sec squared 1 plus sine 1, and then add 1 to make x the subject. So x equals negative tan 1 minus cos 1 in brackets divided by sec squared 1 plus sine 1 in brackets plus 1. You can do that all in one step. And that equals 0.7616 and so on. And we need to round that to 2 decimal places. So the first approximation to alpha, I'm going to call this x2, is 0.76, correct to 2 decimal places.